Okay, so today's agenda is to learn about search techniques in AI. So, with respect to AI, there are two different search techniques called as exhaustive search methods and next heuristic search techniques. So, this is the next concept what we need to learn as part of our syllabus. Also, searching is one important strategy which we need to ensure properly because whenever you are going to solve a puzzle or whenever you are going to address a problem, it can be a game playing or it can be any new strategy with respect to AI. Search plays one major role. Why? Because whenever you want to do any task with respect to a puzzle, you need to understand what are the different possibilities I am having to make a step forward or make a step backward. So as part of that, which are the possibilities where I can go for backtracking and where I cannot go for backtracking. As yesterday I have given you examples. So whenever you are going for a chess game, once a move is kept, we cannot come for backtracking. So also with respect to that, if it is a chess game, there are many different ways you can try to address a problem there. In the same manner, if you're coming to a 8 puzzle problem, you are having an n number of chances to come for backtracking, and that's how searching mechanism will be continued automatically with respect to your AI. So in today's session, we will be trying to learn about these two important techniques, which will be applied further in your uh, problem solving procedure, how searches, different searches can be useful. So when I was explaining about TikTok toy problem, I have explained you min max algorithm because that is one important approach where you can apply it for puzzles. In the same manner, these search methods will be discussed today, which can be applied later on in your sessions. Okay, in your problem solving, that will be very important for us. Okay, so the outcome is we'll be applying these concepts of search methods for various solutions with respect to AI. It can be problem solving, it can be any conclusions or knowledge representations, and what are the learning, whatever you are going to learn now, the same concepts can be applied for any puzzle solvings, problem solvings of your AI. Okay, so yeah, so what are the different types of search algorithms? As already said, we are having two different types of searching methods. One is exhaustive, or we call it as uninformed search. Other one is heuristic, or we call it as informed search. So as part of our learning through our syllabus, these two concepts are again part of our syllabus. Okay, so I just want to share my screen once more about your syllabus to make you understand where are we in our syllabus, because we are moving every day. A concept is being discussed. I don't know how many of you are following regularly, so we need to ensure we are following our syllabus properly. Okay, so yeah, once you can see on the screen what we have discussed till now. These are the concepts which have been covered till yesterday. Okay, today we are at this phase called as exhaustive searches and heuristic techniques, which are the search strategies of your AI. So this is what we are going to discuss in today's session. Okay, we are going to address these things called as exhaustive searches and heuristic techniques, and you can see the next steps called as iterative deep learning and A star constraints are the also part of your heuristic techniques, which will be discussed in today's and tomorrow's session. So hopefully within 3 or 4 sessions we will be at the end of your unit 1. Why? Because uh, in unit 1 we have initially discussed about the basics of AI. The first 3 sessions or 4 sessions where we have discussed about uh, what is AI and what are different phases of your AI, types of AI. All the basics of AI has been explained, and since last 3 sessions we are stressing on problem solving, various applications, how various problems can be solved using your AI, what are different characteristics, what are the control strategies. So all these we have discussed, And in today's session, we'll be discussing about different search methods which are as part of our syllabus, what they have kept in syllabus, and also apart from that, what are the different strategies which are available as part of AI will be discussed. Okay, yeah. So moving on with your class for today. Okay. Yeah. So this is what we'll be learning in today's and tomorrow's session. That is, what are the different searching methods? As said, you are having two different type of searches: exhaustive or uninformed. We also call it as blind search methods. And next one, that is informed, that is heuristic search methods. So you can see on the screen, exhaustive search means having no information about the number of steps from current state to the goal state. So this is what is the understanding about your search methods. So you'll be having an initial state and you need to reach to a goal state, and you call it as a destination. So with respect to that, you need to traverse your tree in a number of possible ways so that you'll be reaching the destination. So when I talk about exhaustive search methods, here you don't know how many number of steps will be applied depending on the approach what you're going to follow. That's why this is called as a blind approach. We'll try to move to the destination in a blind approach. And next one is informed search, or we call it as heuristic search technique, where this will be more efficient than uninformed, because here you'll be exactly understanding how many steps you need to traverse in a tree that will be predefined, and according to that only we will be having a solution. Okay, so this is what is the understanding of what are different types of search algorithms with respect to your AI. Okay, here you can see what comes under informed search and what comes under uninformed search. So uninformed search, which means exhaustive search, here you are having BFS and DFS algorithms, which you already have understanding of what are these approaches. However, we will try to learn about these approaches in today's session. And also coming to your heuristic search techniques, that is informed search, you'll be learning about A star search, which is part of our syllabus. We also we'll be learning about greedy search, which is very important searching mechanism as part of your AI. Okay, so if you are trying to make a note of what we are discussing, you need to keep this in your mind, because on today's and tomorrow's session we'll be mostly stressing on these things. Okay. Yeah. Okay, let's get into the actual topic of today's search. Today's topic, that is exhaustive search. We call it as uninformed search. As I said, BFS, breadth first search, and DFS are the algorithms which can come under these strategies. So in examinations also, if the question is asked like explain in detail about one of the exhaustive search methods, then you need to explain about either BFS or DFS method. So anything, whatever your understanding you already have, the algorithm, whatever you have already learned, the same thing will be again discussed here, nothing new. So if we are coming to AI, the algorithm is not going to change, nothing new is discussed, but the way we understand things will change. The terminology what we follow here is like what is the initial state and what is the goal state, or what is the final state, and how many number of sequence of steps have been followed upon the different approach. That is what we'll be learning as part of your AI. Okay, yeah. So as everybody know, these are the two commonly used search procedures which explore all the alternatives during search process. So it can be BFS or it can be DFS. It will try to explore all the possible ways in which destination can be reached. They do not have any domain specific knowledge, because depending on the tree structure what you're following, you can just traverse your tree and try to reach the destination. So you need to follow the initial state and the goal state and the set of legal operators. This is one important thing we need to keep in mind. You need to start from the initial state. We call it as a route actually, and we will try to traverse through branches, child nodes, and we will be reaching a goal state. The terminology goes like this in AI. So previously when you studied about data structures, then we call it as a root, a child, a branch. That's how we try to make a difference between what we have learned previously and now. The strategy gives the order in which the search space is searched, right? So the strategy what we are going to apply depends on the problem what you are going to address. Okay, so BFS and DFS come under this approach. So just we'll see about the overview of what is this BFS and what is DFS. Okay, so everybody of you already have understanding of what is this approach. Yeah, so you can see a small understanding here. If I talk about breadth first search, the black spots here indicates initially we are starting from a tree node and then we are traversing to the sub nodes, or we call it as a child nodes. When suppose if I say for a root node I am having 3 branches here or 3 nodes, all 3 will be traversed initially with respect to your BFS. And when I talk about depth first search, DFS, initially a root node will be selected and the leftmost node will be selected, and it will be going on till the next phase, and upon completion of that depth, next node will be selected, that is B node will be selected, and that's how search method will be followed. So people who are confused and whoever gave wrong answers in the poll, whatever I have asked, you need to keep this in your mind. What is BFS and what is DFS? So just you need to recall your concepts, what you have learned previously. Yeah. So we'll just have a look into what is BFS algorithm and what is DFS. So as I said already, you'll be in BFS, the breadth will be identified for a parent node, for a root node, how many number of childs are there. All those childs will be traversed, and in the same manner, again we will start from one more subroot and we'll be traversing all the child nodes. This algorithm searches breadthwise in a tree or a graph, so it is called as breadth first search. Yeah. So the BFS algorithm starts searching from the root node, as already said, and expands all successor nodes at the current level before moving on to the nodes of next level. So it will try to traverse all that nodes under its root, then under parent, and it will go for the child in the next phase. So as said, BFS follows FIFO queue data structure, and DFS follows LIFO, last in first out. So this is what is asked as part of your poll question. So people who gave wrong answers, please keep this in your mind. BFS uses FIFO approach and DFS uses LIFO approach. Okay. So these basic things about advantages and disadvantages you already know. So this PPT will be shared with you. You can just try to learn about that. So next we'll be discussing about DFS, depth first search. So as I said, for a root node, if I am having 3 child nodes, and for the first child node, if I have 2 more childs, so it will be following in the depth manner, that is from root to subroot and subroot to the next child. That is how depth first search will be traversing. So this uses LIFO approach, and as I said, BFS goes for queues and DFS go for stack data structure for its implementation. So the process of DFS algorithm is similar to BFS. So the algorithm is, there is no much change, but the understanding is different here. Okay, 1 second, just give me a minute. I'll just try to show another PDF where you'll be having understanding of what is BFS and DFS. Okay, so I hope everybody can see my screen. A PDF file is being displayed here. Yeah, so you can just look onto the screen for just a minute. We'll be trying to see what is BFS. Okay. Somebody give me a message. I just like to look into what is that. Yeah, Dikshit, yes. Okay. So on screen, you can see what is DFS, depth first search. And as I move down, you can see how it is being traversed from A to B and B to D, a small animation type thing here. You can observe here properly. And from D to again H. So once H is completed, it is going on for E. So this is one important understanding what you need to have as part of your BI, DFS. Okay. This is what is about your DFS. This is how the search strategy follows by your DFS. And once moving on for your BFS, you can see how BFS can be implemented. So initially you can see from A to B, again it's not going for D, it is going for C. This is a search strategy followed by your BFS. That's why it's called as first in, first out. Okay, I think everybody now understood what is the basic difference between these two approaches. Okay, yes. Any more queries, guys, from anybody? You can just ask me to unmute you and you can discuss. So I'm not going deep with this BFS and DFS, hoping that everybody already learned about this BFS and DFS. We are not concentrating on the algorithm as of now. I just want you to ensure, make sure what are the different strategies which are available as part of your BFS, as part of your search methods. So as part of your exhaustive search methods, you are having BFS, DFS, and also uniform cost search algorithm. This is something new about what we will be discussing. So this is a searching algorithm used for traversing a weighted tree or a graph. So definitely whenever a tree or graph is having a weight, or we call it as a cost, then you can apply uniform cost. That is, whichever that path is having less cost, that will be the best path. So similar to a shortest path, how we will be selecting, the same manner, this is about uniform cost search algorithm. This algorithm comes into play whenever when a different cost is available for each edge. So this is very common thing, what proper understanding. So whenever you are having different cost for each node, we'll be trying to select the lesser cost element as a path. The primary goal of uniform cost search is to find the path from starting to the goal node which has lowest cumulative cost. Suppose if I say I am having a root element called as A, subroot called as B, C, D, and also I'm having for B like E and F. If I have cost for each element, how I need to traverse. So I can just make you understand with respect to this diagram here. Yeah, suppose here you can see I want to move from S to D, that is what, or S to G. So here you can see, because it's a tree approach, I need to go from S to D to G in a single approach, because I don't have multiple paths here. But whenever I have a multiple paths to reach a solution, then I need to go for uniform cost search method. Yeah, here you can see that representation, how we will be traversing with respect to uniform cost. Here you can see at the root element the cost is 0. For A it is given as 1, 4, 5. So if I want to reach G, I'm having two different paths. That is, from S, D, G is one path, and again S, A, B, G is other path. So if I want to reach from S to G, what are the different methods I need to follow according to the cost? Suppose if I move with the left node, the cost is 1 plus 4 plus 5, that is 10. That is the cost I am getting. If I move with the right node, that is S to D, D to G, my cost is 11. So definitely I need to go with the path whichever is having the less cost. That is what we call it as a uniform cost approach. This is one important approach what we need to understand as part of your exhaustive search method. Okay, so this is about your exhaustive search method. And next, advantages: uniform cost search is optimal because at every state the path with the least cost is chosen. Yeah, definitely the cost is less. That's the reason it will be the best approach. And what's the disadvantage? It does not care about the number of steps. So you can see that in the previous slide, if I go with the right side implementation, you are having the 3 steps, but here it is for 4 steps. So optimally it is reducing the cost, but number of steps are more. It may take some lot of time compared to the previous one. The same manner, whenever you are having different possibilities to reach your destination, sometimes the path may be more but the cost may be less. That's how that can be called as one disadvantage of uniform cost. Okay, this is what is about your exhaustive search techniques. Now we will try to learn about heuristic search methods, or we call it as informed search methods. As part of your informed search, as I said previously, you are having different types of algorithms here. In informed search, you are having greedy search method, A star search method, which we'll be discussing in the further classes. Graph search, iterative deep learning search is one important method what we'll be learning as part of your informed search. Okay, before going on for different search method, let's try to understand what is actually informed search. So what is uninformed means, there in uninformed you are not going to say how many number of steps are available as part of your starting to ending state. Depending on the solution whatever you want, you'll be trying to move a number of steps that may lead to many steps. But coming to your informed search or heuristic search method, here initially we will be trying to say how many number of steps do we need to traverse. That is the condition what we need to follow, and that is what we call it as a heuristic function here. Okay, in informed search, it will try to reduce the amount of search that must be done by making intelligent choices. So the choice should be intelligent one, that is traversing from one node to other node. It should be an intelligent move, then only that will be leading to less number of steps. That is accepted for expansion. So in general, this is done using a heuristic function. So we'll be learning what is this heuristic function. In examination also, they'll be trying to ask you with respect to this, what are the different heuristic search techniques. I explained about heuristic function in detail. So heuristic function is like, we'll be having information about the starting and the ending goal state, which will be helping us in getting some efficient search. The information is obtained by something called as a heuristic function here. I'll try to explain about that in the upcoming slides. Yeah. In an informed search, a search function that estimates how close a state is to the goal state. Yeah, I'll just try to show you here. Here you can see, similar to your uniform cost, here you are having some h equal to 9, h equal to 4, h equal to 2. Likewise, you'll be having some heuristic value here. So we'll try to explain about that in detail in the upcoming sessions. Yeah, before that, I just want you to understand what is a heuristic search method here, how it is being different from uninformed search. That is what is the proper understanding about today. In tomorrow's session, we'll be trying to stress over different heuristic search techniques, and that's how we'll try to move on in the upcoming sessions. So this is an overview about what we'll be discussing tomorrow, the different methods available as part of your heuristic techniques. So today, I just want to end with your exhaustive search methods, and tomorrow in next session we'll be discussing about informed searches called as greedy approach and all the different approaches.